All right, last part of Unit 7, we need to talk about metals and what the bonds within the metals look like, and those are called metallic bonds. Now, I know metals aren't ionic, but they share several properties with ionic compounds, so that's why we're going to talk about them in the ionic unit. The bonding in metals is based on the attraction of particles with unlike charges, just like bonding in ionic compounds with cations and anions. And metals often form lattices in the solid state, so they're going to have the same kind of physical structure as the ionic compounds with the crystal lattice. So in that lattice structure, the metal atoms overlap and share their valence electrons in what's called a sea of electrons. Now, here's what that looks like. Okay, so up here, these are all of the metal cations. Now remember, this is just a metal, so this might be gold or zinc or tungsten or whatever the metal happens to be. So all of those metal cations are here, and then all of the valence electrons are just kind of floating around, hanging out, spreading themselves out to all of the metal cations in a sea of electrons. So the valence electrons aren't held by any specific atom. They can move easily from one atom to the next, and we call a metallic bond the attraction of a metallic cation for delocalized electrons. Delocalized meaning spread out to all of the atoms. So metallic bonding is the attraction between the cation and all of those delocalized electrons. Now, the properties of metals can be explained by this metallic bonding. For example, melting and boiling point. Metals generally have moderately high melting and boiling points. Now, obviously, mercury is the exception because it's a liquid, but other than that, the melting and boiling points of metals are really pretty high. Now, the boiling points are extreme compared to the melting points because of the energy needed to remove an atom from that whole group of cations and electrons. Because of all that extra attraction, it's going to be really hard to turn those metal atoms into gases and make them boil. So they have extremely high boiling points. Some of them, as you can see in the chart, have extremely high melting points like copper and silver. Some of them are low, but in general, the melting and boiling points will be very high. The mobile particles in the metals can be pushed or pulled, which makes metals malleable, ductile, and the durability has to do with the strong attractions between those cations and electrons. So in our picture down here, unlike an ionic compound, when you hit a metal with a hammer, all you're doing is just pushing the metals over. You're deforming it. So metals bend. They stretch. You can hammer them flat. You can stretch them into wires. They don't shatter like ionic crystals do when you hit them with a hammer because that sea of electrons lets those atoms be pushed or pulled past each other. Thermal and electrical conductivity is due to the mobile electrons. Because those electrons can move around, they can absorb or they can move heat or electricity through the metal. That's what makes them good conductors of heat and electricity. The electrons can also absorb and release photons, which creates the property of luster, and that just means that metals are generally shiny. They're shiny, silvery metals, most of them. But it's all about those electrons being able to move around. That's what gives them the ability to conduct. The strength and the hardness of a metal depends on how many electrons they have. So not only are the two outer electrons in the s orbital part of the electron C, but also the d orbitals. So as the number of electrons increases, the properties of strength and hardness also increase. So you find really strong metallic bonds in chromium and iron and nickel because they have a lot of d electrons. But alkali metals that don't have any d electrons, they only have the s electrons, they're considered soft because they have only the one delocalized valence electron. So what I want to show you is a little video that kind of shows you what sodium metal looks like. It doesn't look like your normal metal. It's not what you think about when you think of a metal. So I want you to see how soft that metal actually is. Alright, so in this video there is 3-pound chunk of sodium metal, and as you can see they're using just a normal kitchen knife to cut a piece of that sodium metal off. So the alkali metals are generally very soft. Some of them actually you can just bend with your hands. You can cut the metal down the middle. But as you can see, it's still shiny and silvery just like other normal metals are. Alright, and the very last thing we want to look at with metals are metal alloys. And an alloy is a mixture of elements that have metallic properties. Now generally, the elements are going to be metals. Sometimes they're not. A lot of times carbon is mixed together to make part of an alloy, but most of the time they're metals and they're just mixtures. But the properties of the alloys differ somewhat to the properties of the elements they contain. Generally, metals are mixed together to give very specific properties that you can't get with pure metals by themselves. For example, with different types of silver, okay, sterling silver versus pure silver, mixing it with a little bit of copper, like you can see right there, is going to make it a little more durable. It's going to make it a little less tarnished. Different types of steel are used in different things. Stainless steel versus spring steel versus all the different types. And all of those properties depend on the elements that are mixed together and the ratio of the elements that are mixed together. And we're going to be doing a lab looking at how you can actually change the properties of the elements based on heating and cooling of that particular alloy. We're going to take some spring steel and see if we can change it into a different type of steel with heating and cooling. So that wraps up our unit for ionic bonding and metals. We're going to be doing lots of hands-on in class, so make sure you bring your notes to class.